Well, good evening from Emerald Hill Skies. We're coming to you tonight from the outskirts of Louisville, Kentucky. My name's Doug, and welcome. We're glad that you're here. I think Mike checked in first tonight, so Mike, you get the prize for checking in first. Mike asked, well, what was the prize? We'll have to dream up something for sure, Mike. Tonight we're back with lots of images from the Hidden Treasures. And this is a Stephen James O'Meara book, and we have revisited, I guess, let's see, we've been to, trying to think, the Caldwell objects recently, and we've caught up on that. We've also been to, boy, do I not have my, I guess I don't have my Herschel 400 book here because I put it back on the shelf since it'll be December before we can catch those last three objects from the Herschel 400. So tonight we're bouncing over to Hidden Treasures, and we are not going to that one that you see in the title. Let's put a new, let's see, here's our sky. Where can I change that title? How about if I change it right here? And how about if I just say something like NGC 2546, and it's an open cluster in puppies, or however you say that, an open cluster in Puppis. Puppis. How do you pronounce that? We need a pronunciation guide for that. You're seeing it right there. Now, this is a kind of a confusing little cluster when you stop and think about it. I don't know if this particular part of the, this is a live image, by the way. I don't know if this particular part with that little satellite flying by there, if this caught the eye of the discoverer, who was Lecaille. Herschel saw it in, see, a cluster of, I don't know if he says the year here. It's inspired discovery by Lecaille. And he says, one sees with the naked eye two neighboring confused groups of stars, but with the telescope, they are small, distinct stars in very great number and very close together. It's a young, 30 million years old, and about the same age as the Christmas tree cluster. Then he tells you how to find it, and he says it looks like it's elongated, magnificently rich. I don't know if this looks magnificently rich to me. He says you include everything in this entire area, I guess. Huh. But I do see right here, you see this part right here, that looks a little more clustery, doesn't it? But I don't know if this cluster strikes my eye or not. Okay, let's get our session started here in the session browser. We're going to say that say new session, and we're going to go till 4/18/2023, and let's just put, you know, 1 a.m. there just to be sure. 1 a.m. and there's our session. This would be session 116. So observing session 116. And we'll save that. We're making our notes here in Deep Sky Planner 8. So now that we've got our session done, we'll add an observation here. And let's make sure we identify the session. There it is. And we'll say this cluster honestly didn't seem very obvious to us. there were some gathered stars, but frankly, I'm not sure I would have noticed it enough to, quote, discover it. Around 20 stars, 3,200 light years away, and said to be 30 million years old. So that's kind of young as far as clusters go, isn't it? Yeah, young, we'll say. Okay, so that's NGC 2546. It's hidden treasure number 46 on O'Meara's list. All right, Mike, it looks like we have 4 or 5 of us on tonight so far, but you're the only one that's checked in. If you're observing with us, please, astronomy is a team sport. Go ahead and identify where you're observing from, please. We'd love to see where you are. So here we go. Next object is hidden treasure 56. It's NGC 3521. So let's slew to that. And you might have noticed tonight that we've not been able to get our scope cam to come up. So we're just going to have to show you the ZWO ASI2600MC monochrome camera as it watches the sky skate by. And that's truly what you're seeing there, is just kind of skating by. We'll make it a little bit bigger in this picture. You can sort of ride on top the scope, so to speak, and look at the sky as it glides by. Azray, good to have you on from Arizona. And you'll see when the bright stars go by that there's quite a bit of, what would you call that? Gliding or streaking, I guess, streaking. And that's because these are 3-second time exposures. Each time the ZWO ASI178 monochrome camera snaps a picture, it's a 3-second time exposure. Can anybody make out the Big Dipper over here? The Big Dipper's on the left. And is this Leo? Looks like Leo, doesn't it? There's the tail of Leo. Let's see if I can get to this. Maybe you can see my mouse cursor. Is this the Big Dipper, Ursa Major, and then this is Leo, the lion, and you can make out, I think, the, can't you? Isn't this the backwards question mark of Leo? So let's see what we've got here. Let's come back to our screen, and first of all, let's do our title correctly. This is NGC 3521, and this is a galaxy in Leo. A galaxy in Leo. Okay, let's change our name up here. This is NGC 3521. Look at the way that drops down. Oh yeah, that's, I wonder if that's past targets or what. Anyway, I wonder if we're going to have to live stack this. It looks like we are. So let's change. We're using a ASI2600MC Pro for this. Let's set that ASI2600 on 20 seconds, and let's go to a gain of 100. And now let's start that live stack. You know what we should do before we live stack? We should do another plate solve to make sure we're looking at the right part of the sky, because this is just our second view of the night, and in the first couple of views, you'll recall, we can be quite a ways off. We're using observing from a Pier-Tech Tele-Station 2 observatory. And you can see at the bottom of that observatory on the floor there is a Pier-Tech Adjustable-Height pier. And on that pier is an extension, first of all, and then an iOptron CEM70G mount. It's all the black portion there. And then a RASA 11. And at the business end of that RASA 11, you've got an ASI2600MC Pro on an Octopi-Astro camera interface there fastened to the connector, the corrector lens or corrector plate of that RASA. These are not live pictures, these are snapshots, but this is a live picture. And now let's go back to live stacking. We're going to set on 20-second exposures and 100 gain and start live stacking, and we'll clear the last live stack. This ASI2600MC Pro camera is an APS-C size sensor, so it gives a pretty large view of the night sky. The first thing that we usually do is try to do a display histogram restretch. And then we try to do, that's pretty bright, isn't it? A stretch, auto stretch of the main histogram, and then a color balance, and then we bring the black level so that it matches up with the black level of the frame, and then we start looking for the object, and right there it is. Again, this is hidden treasure number 56, NGC 3521. And the first couple of 20-second frames at least show us that this is a lens-shaped oblong spiral galaxy. You can see that bright core already after just the first 20-second exposure. And with every subsequent exposure of the live stacking process, if you're new to the channel, you can see that the galaxy, which is going to remain pretty steady in the picture, it gets clearer and clearer. And then the grainy parts of the light pollution in the night sky, and there is quite a bit of light pollution. You can see in the sky cam that glow around the horizon. This is the horizon. We're sitting on our side in this equatorial mount, so the horizon is really on our right. With that glow, it produces a lot of little grainy artifacts here in the screen. But those artifacts change with every exposure. They're never quite the same. They're kind of floating around. So what that does is it allows the software, which is SharpCap, to begin picking up on which of those grainy elements is fluctuating and which is not. And the elements that do not fluctuate, it assumes are probably a star. And the ones that are fluctuating, it assumes that it's part of the grain. And so what that does, it makes our object become more and more visible, and all the detail starts to show up. Look at this, these little dust trails out here on the side of the spiral galaxy. This begins looking more and more like the Milky Way with every subsequent frame. Let's go to this description that Stephen James O'Meara gives. He says this is a mixed spiral, and he writes, deep in the far recesses of southern Leo, hidden from view due to the lack of bright stars nearby, lies the beautiful spiral galaxy NGC 3521, one of the most neglected bright galaxies in the heavens. It is equal to or nearly as bright as many of the Messier objects, the Messier galaxies. It is full magnitude brighter than Messier 108 in Ursa Major, yet few seek it out. NGC 3521. It lies on the celestial equator. It also escaped the careful eyes of Messier, Messiaen, and all their comet-seeking contemporaries. Not until February 22, 1784, less than 2 months after William Herschel began his systematic search for nebulae with his 20 foot telescope. On December 19, 1793, did light from NGC 3521 first fall directly on a human eye. He called it a bright nebula, and then he tells something about the history of all the other folks that have observed it. He says it's a mixed spiral having both a bar and also a normal spiral. In photographs, it shows a very small and very bright nucleus nestled in a hexagonal-shaped lens from which many knotty and filamentary spiral arms flee outward. The inner lens has such a high surface brightness, but the thin spiral arms do not. Mottled segments. Two dusty structures. Tells people how to find it. Talks about what a great job Herschel did to find it. View the galaxy in all its subtle grandeur. See if some subsurface emotion does not suddenly well up inside of you like magma in a volcano and cause you verbally to explode. Well, I don't know if I'm going to explode tonight, but it is a fine-looking galaxy. Now that's 100% of our APS-C frame. Looks a little sharper at that 100%, doesn't it? So we'll just add an observation here, and we'll say, this is indeed a beautiful spiral with lots of mottling in its rings and outer arms. How far do you guys think this is? $23 million light years. 23 million light years distant. Wonder what the angular extent is. We should be able to tell that from one of our, 11 arc minutes. That is pretty good size, actually. NGC 3521. That's a beautiful one. Wonder if we can make it any brighter. Looks a little bit like something out of Star Wars, doesn't it? Lando Calrissian would be right there in the middle on some platform. Well, there you go, 3521. All right, let's go to the next target. We'll use our sequence now. And it'll ask us for the name of the next target, and that would be NGC 3621. That was 3521. Next is 3621. So let's slew to it. I'll go ahead and show you the view for the scope cam. Even though we can't seem to get the scope cam to come on, let's try it one more time. Let's see. Gonna switch for a second to another camera. Just see if we can wake it up. Boy, it just won't wake up. Try one more time. We'll switch it out to the guide camera out in the, I don't use the guiding very often, but we'll switch it out to the guide camera. And now we'll try to go back to the scope camera. Boy, it just won't wake up. So sorry. No scope cam. But what we can do is show you for a second the sky cam, which is the ASI178 monochrome camera that ZWO makes. It's here on the end of this little equipment plate. We sometimes affectionately refer to this as our outrigger on top of the RASA. And on top of that equipment plate, we also have a Pegasus Astro USB distribution box and a Pegasus Astro micro power box that's powering everything up here, cameras and all, dew heaters and all, and it's bringing it all in to the rig rack at the bottom of the scope. So this is mounted sort of vertically, and you can see all the different power distribution boxes here. It comes in from the scope, and then it sends it along a fiber optic relay and brings it into the office where I'm sitting. Let's go to the, we're looking at NGC 3621. So let's show this on our chart. Let's go to our chart here, and I think it'll help for a couple of reasons. This is my truck parked here. And although this is a photo panorama that I shot earlier, that is in fact where my truck is parked tonight. And this is the building in which I'm sitting. And that's the door that goes in from the side. But here in the corner is my corner office. And if we could see this live, I wonder if we can see it live. Let's go to the Skycam. And let me come over there with you so you can see my mouth. There's my truck. No, we're looking too far off to the southwest here, so we can't see the building live, but we'll come back to it another night. So let's go back to Stellarium, which is the planetarium software we're using. You can see we're angled here toward the south. It's sort of like east, no, it's south-southeast. And you can see the azimuth, we're looking over just 10 degrees or so east of south. And these constellations aren't really well known here. This is Hydra, scattered out over a big part of the night sky. Hydra. I think they also starred in a James Bond movie. Then here's Crater and here's Corvus. Virgo's over here, so that's kind of a little more well known to give us a little better view of this frame galaxy, otherwise known as NGC 3621 in the constellation of Hydra. 3621 is 22 million light years away. Thank you, Azray. So we're going to add an observation here. And we're already going to start collecting our thoughts. 22 million light years away. Um, 22 million light years away. 22 million light years away. Now this is the planetarium software. So this is like, you know, something you could download on your computer, Stellarium. But this is the live view. And let's hit our display histogram auto stretch and do the same thing with our big histogram. Do a auto color balance. We have a really nice night tonight. It's just inky black out there. It's just completely moonless. Dark as dark can be, except for that light pollution. Now let's zoom in a little bit. This is a galaxy in Hydra. I don't think this is often seen. 100% is right there. Let's do a focus run after this. You can see the scope is starting to come out of focus. That means our temperature must have varied a little bit. But we'll wait until after this object to run that focus run. It's about 3 minutes and 40 seconds, 22 million light years away. And this is Hidden Treasure 57. At the top of his book, O'Meara has these little black bars, and they instantly let you scan to see which object you're looking at. And then the next thing he does is give you a locator map if you're observing visually. And then he gives you an astrophoto that somebody captured, as well as a summary and a lot of text about the object. So while you're watching that form up, I'll just check out this text. He says this is a mixed spiral. Hydra is host to innumerable galaxies, many of which can be picked up in small amateur instruments. Its biggest deep sky prizes, of course, are M83, a magnificent spiral galaxy, and NGC 3242, which is also known as Caldwell 59, the ghost of Jupiter planetary nebula. But spiral galaxy NGC 3621 is another bright denizen of Hydra. Now I need to learn to use that word denizen. What does that even mean? Denizen. Denizen. Definition of denizen. An inhabitant, a resident, a person who regularly frequents a place. The denizens of a local bar. A denizen is a resident. Okay. So Spiral Galaxy 3621 is a denizen of Hydra. It's not included in many popular handbooks. And though it's smaller than M83 and a little bit fainter, it's interesting, O'Meara says. It is in the low south side, and it lacks some bright stars, so maybe that explains the neglect. But in long exposure photographs, it's a remarkable pinwheel, just 25 degrees from edge on, 93,000 light years across. So we'll find our observation panel here, and we'll say 93,000 light years across, 25 degrees from edge on, luminosity of 13 billion suns. Small bright nucleus nestled in a bright ellipse of spiral arms, cut by rifts of dust and dappled with numerous young star clusters. See, I just want to say words like denizen and dappled when I grow up. It gradually unwinds into a fainter outer halo. Yeah, I would say so. This is 89%. We'll go into 100%. It still looks rather splotchish for us, doesn't it? We're going to try to run up these mids a little more. Now it looks like a slightly brighter splotch. What do you guys think? Folks, good to have you on from Australia. Good evening. We're looking at NGC 3621. I better change my title here, lest somebody happen along and think that we're looking at 3521, because this is now 3621. It's a galaxy in Hydra. Sorry. Okay. He goes on to tell the history of people finding it. He says stars that are near it. He talks about from his dark skies in Hawaii. Makes all of us rather jealous. Says it's a fabulous sight with 3 dim stars forming a cap. See the little cap? It's like a dunce cap. See the dunce cap on the end? That's nice. If he uses averted vision, you can see several bright areas. He follows 2 spiral arms that form a backward S. See, here's one. Man, the guy's got good eyes, doesn't he? Oh, here's the other one. We're going to go focus as soon as this is done. So let's go back to our logging and say, O'Meara pointed out a backward S that we could make out in our rapidly evolving focus. Mike, Jerry. Are you not looking at the sharp cap screen, Mike? You should be able to see it. Oh, I fixed it. Okay. We're going to do a focus run right now, but it's kind of just a loose spiral. We can't see the backward S. Dappled veins of dust that riddle the galaxy in photographs. Bright nub of an arm extends. Blotchy arms, a thin arm. Ah, look. See how we can barely make out the bar across here? Barely. It's not helped that our focus was lost here. All right, so we're going to wrap this up and say we could barely make out the bar across our view. All right, let's just disconnect the camera here very quickly and open up Nina. We'll reconnect the camera. I wonder, I forget if I can connect the focuser at the same time. Yes. So the focuser is not selfish, it's just the camera is selfish. Then we'll go to imaging down here. And start our autofocus run. This autofocusing is kind of fun. Stu, welcome aboard, Stu. NGC 3621 is a field spiral galaxy about 22 million light years away in the equatorial constellation of Hydra. The galaxy is around 93,000 light years across and is inclined at an angle of 25 degrees. Stu, what's it like in New Zealand today? I have a feeling that you are around 10:30 a.m., right? So you probably have a cloudy morning in New Zealand, in Tauranga. Folks, I'm guessing in Australia it's a sunny day today. You guys will have to tell us if we guessed correctly. Oh, I was going to tell you about the autofocusing run. Nina has a neat little plug-in, and this little plug-in allows you to snap a couple pictures of the stars at a particular focusing stop. And then it moves the focuser a little bit, like it moved it from stop number 29,810 to stop number 29,790. And then it takes two more pictures, it moves it again, takes two more pictures, moves it again, takes two more pictures, and so on. And when it sees that the stars are getting ever wider, like expanding donuts, it's so out of focus, no longer a pinpoint, it says, okay, I can measure now that the half-flux radius of these stars is growing. So now it knows that it's reached the best focus that it can reach in going in one direction. It's running out of focus. In other words, a worsening focus. And it goes back to the best one it could find, and it starts going in the other direction, taking more pictures, moving the focuser a little bit at a time, taking more pictures as it goes. And what that allows it to do is compare the half-flux radius and make this what we hope will turn out to be a nice little kind of a hyperbolic curve. And at the bottom of this curve, because the half-flux radius will be the smallest possible radius that it can be, the little plug-in in Nina will deduce that that's the sharpest focus. Now, why is that? Because the pinpoint star has a smaller half-flux radius than the Cheerio stars that are wider and donut-shaped. And so you see we're reaching what we think is the bottom of the hyperbolic curve here. And as that hyperbolic curve starts to round its corner and begin to, hopefully in a minute, pop back up, we'll know that that's the bottom of the focus, and the plug-in will take the camera to that position and release control back to us. Stu tells us that it is actually 2:30 p.m. So 10:30 p.m. So it's 12:30, 14 hours offset. It's a bit cloudy and 25 degrees Celsius, which is rather warm. 21 would be room temperature, so that's about 72-ish. You add on 8 of our Fahrenheit degrees, so that's around 80 degrees Fahrenheit, so that's kind of warm. Meanwhile, back on our hyperbolic curve, look how the curve is bottomed out. And now we're going to assume that our focus will start seeing, oh, I was wrong. We're still bottoming out. We're going to assume in a second that our focus has reached its smallest half-flux radius. And it'll start to round back up again. Now, why does this happen? 19 hours. Thank you, Mike. Why does this happen? Well, it's because for every couple of degrees, the mirror and the telescope are changing shape a little bit as the cold contracts everything out there. And you can imagine with the cold contracting everything, then you get to a point that the telescope kind of loses its sharp focus because it's no longer in the range that it's set up earlier in the evening when you focused. So there you go. It does take a minute. Now the Celestron RASA, this is an 11-inch, has a notoriously small focus range. We're going to trust this, even though there was a little bit of a bump here at the bottom. And that was just because of atmospheric disturbances. We're going to trust this. We're going to go back and go to equipment again, disconnect the focuser, and go to the camera, disconnect the camera, close Nina, come back to SharpCap, reconnect the camera, stop live stacking because that really doesn't have any more meaning. And that's better focus. I don't know if it's perfect, but it is better. We're zoomed in at 100%, so at least there are no donuts there now. So it's pretty good focus. Not quite perfect, but as you look at it right there, yeah, that's pretty good. Our next target is NGC 4214. You might say, well, where do we get these targets? Well, we get them from O'Meara's book. There's the Skycam view. And O'Meara dreamed up this list. The Hidden Treasures list is an O'Meara creation. And then he wrote this book, and it became famous enough to where now we have this Hidden Treasures list. But really, it's just in O'Meara's mind. But we use this because it gives us another list of targets to seek out. How about that? Okay, so this is NGC 4214. I'm going to do another plate solve here. NGC 4214. NGC 4214. And it's a galaxy in CVN. Cervantes. Not really. It's in Ganesh Vanatici. So the abbreviation for that is evidently a C and then a VN. Dici. All right, we had a 0.24 degree correction there. So let's go to our live stacking now. We're going to switch to a 20-second exposure at 100 gain and live stack and clear the live stack. Boak says we're moving into colder months here in Southeast Australia. I'm having dew issues on my corrector plate. I need to get a dew shield and heater bands to extend my imaging time. You know what, folks? We are big on dew shields. In fact, let me show you here. This black band that you see toward the top of that picture of the RASA, there's a black band, that's the dew heater, and then the black extension you see on the end of the white RASA tube, the optical tube assembly, this black thing you see extending all the way off the picture, that's our dew shield. So sure enough, we believe strongly in dew shields as well. In fact, we even have a dew shield on our Skycam, a little ASI-178 with this little tiny fisheye kind of lens here, 155 degree view or so. We even have a dew band there, not a shield, but at least a dew band. So we are big believers in dew shields and bands and such. Boak says I use a hairdryer on the corrector plate, but that puts my telescope out of focus. If I refocus, it goes back out of focus again when it cools back down. Well, that sounds like a terrible problem, Boak. So you're going to have to get, indeed, dew band and dew shield. NGC 4214. GC 4214. Stu says is a dwarf barred irregular galaxy 10 million light years distant in the M94 group, both larger and brighter than the small Magellanic Cloud, which I've never seen. It's a starburst galaxy, and starburst galaxy, as you guys know, it's kind of famous for birthing stars, so you end up seeing more supernovas here too, supernovae. Let's see if we can get this thing to show up. What a unique looking galaxy. How odd is that? Boy, it is a starburst galaxy, isn't it? You can just see stars popping out of it. Look at all this nebulosity. And I've always heard that that nebulosity makes for a good star-birthing galaxy because there's a lot of dust, a lot of hydrogen, a lot of different kinds of gases to coalesce and form stars through the gravitational attraction of the core. Can't make out much of a bright core. That might be the core there in the middle. Look how it looks like a little tiny spur shooting up. Almost like the one in, what is that, M85? This looks like it might be worth going to look at this in NGC 4214. Oh yeah. Oh yeah. That is indeed a beauty, isn't it? Now this is not our live shot. This is from some kind of, Hubble or the large whatever sky survey. Let's go back for a minute and see if we can see. Sorry for the bright. Let's see if we can see. This is from some kind of, Hubble or the large whatever sky survey. Let's go back for a minute and see if we can see. Sorry for the bright. Let's go back for a minute and see if we can see. Sorry for the bright. Let's go back for a minute and see if we can see. Sorry for the bright. It is the Hubble. ESA and the Hubble Heritage Team. Captured by the Hubble. Is that not beautiful or what? Now I see why Stu was talking about being larger and brighter than the Small Magellanic Cloud. Look at all these red parts that are hydrogen. Let's see what this looks like in Stellarium. My goodness. Oh, here we go. Yeah, not a great shot. They didn't use the Hubble view in the Stellarium. Close to the Silver Needle galaxy. Look at that. Wonder what our field of view. Not enough to show the Silver Needle, just outside the view. For context, we're looking over the eastern sky and pretty high up. Right now it's at 60 degrees, 59.5, above Boötes. And if you think about the backward handle of the Big Dipper, it would be in the satellite dish view here in the picturesque constellation of Canis Venatici. I'm just kidding. Canis Venatici has like these 2 stars, and that's the whole constellation. Sorry, I don't mean to make fun. I shouldn't laugh. But this is a beautiful galaxy in Canis Venatici. Now let's go to the live view. Look at this. That's 6 minutes. And it's already beautiful. That's 120% of our APS-C frame. That is really beautiful, isn't it? Wow. So in our observation, let's say super unique looking galaxy. Stu says it's irregular and barred. Now I'll tell you, these irregular galaxies are sometimes caused by a collision with another galaxy. And I wouldn't be surprised if we find out someday it was the Silver Needle galaxy that is interacting with this. But I don't know that for sure. Look, there's another galaxy out here, NGC 4190. It could be that one. This is Hidden Treasure 59. Wow. Omira says the large Magellanic Cloud that you guys see in the south, if we could reposition it so that it's 11 million light years from our Milky Way, which is the distance of NGC 40. Is that right? 59. Oh, it's equal to 4228. So this is 4228 and 4214 both. Then it would appear very much look like this hidden treasure, a linear extent of 30,000 light years. How about that? It's a chaotic wonder. Hubble could even make out the bar. Isn't that wild? He says these bubbles, I don't know if we're making out bubbles. Let's go back to the Hubble view for a second. So these bubbles So we should see a bright nucleus and then a bubble out here to the edge. Bright nucleus. Oh, I see. So this is a bubble here. See that little, looks like a kind of a triangle? Now let's go back to the planetarium software image or the Hubble image. That's that triangle there. So these bubbles chumps. I see. One chump is 4214 and the other chump is 4228. Bubbles. Wow. 4 billion suns in the entire image. Enormous bloody yellow mess. A yellow amoeba that's been hit by a truck. Highly resolved view of star formation across the galaxy's face. Filigreed clouds of glowing gas surround at least 6 bright blue star clusters. Fast stellar winds. The activity is so great, it is sometimes referred to as a Wolf Rayet galaxy. These bubbles are due to the fact that the most massive stars in a starburst spend a large fraction of their lives buried inside their original molecular cloud. We're seeing them just as they are emerging from this envelope. Hundreds of massive blue stars at the center of this middle array here. Young stars are being birthed there. Each of them would be 10,000 times brighter than our sun. A vast heart-shaped bubble. Must be this. Heart-shaped, upside-down heart. I guess that must be the bottom of the heart pointing upward. Well, that's 12 minutes. That's the best we're going to get. This is a beautiful galaxy, though, isn't it? The Hubble view hypnotized us. This is indeed a true hidden treasure. Can you understand why O'Meara would write this book filled with these kinds of tons of hot, blue, hot, bright stars in the center? It's amazing. All right, off we go. We must travel on to the next object, which is NGC 4216. NGC 4216. And we'll just show you what we can of the sky here as we travel to that. (4216). A galaxy in Virgo. You can see where we're pointing. Let's go here and look at Stellarium. Oh, we better show chart. Isn't this fun? In just one click we can say show chart and it'll take us directly there. Okay, so see Virgo's arms open. So So we're looking for this keystone shape. And look at Leo, and look how this galaxy is right off of the end of Leo's lion tail. Now let's go back, oh, sorry. Let me let you see so see Leo's lion tail. And there's the point of this galaxy. And then here's Virgo with the open arms. Now let's go back to the sky view. Excuse me. So in the sky view, we can see the Big Dipper. Wow. Here's Leo's tail. Here's that keystone. And here's Virgo. Here are Virgo's arms. There's the one arm. Here's the other arm. And this is Virgo's keystone. So right off the end of the lion's tail right here is where we're going to be pointing. Wow, this is rich in galaxies. Wow, that's beautiful, isn't it? Deep sky image annotation. It's a little bit off because the scope had to reposition. So when that happens, we'll just do a plate solve only. But look here in the middle. So here's the galaxy that is our target, 4216. Tons of galaxies in this view. So here's 4216. But now let's back off and look at the whole field. And we'll use deep sky image annotation here to (4216). Here's a galaxy not labeled, IC3094. All of these IC are galaxies. Here's 42808, which is not on the hidden treasure list. 4193, 4189, all these other IC galaxies. 4200. None of those other galaxies are in the hidden treasure list, but you notice we're right on 4216, spot on here. It is a beautiful field, isn't it? Just beautiful. Wow, this is a beautiful galaxy. I wonder if that star is in the galaxy or if that's a foreground star. 4216, Stu says, is a metal-rich intermediate spiral not far from the center of the Virgo cluster, 55 million light years away, nearly edge on. It looks like something out of a Jetsons cartoon or a, this is number 60, Hidden Treasure 60. It's a picture-perfect galaxy in Virgo. Tells where it lies. It's inclined to our line of sight by just 1 degree. Huh. Sufficient to let us glimpse in stunning clarity its bright core, nuclear bulge, luminous arms, and spiral dust patterns. Can you see the spiral dust patterns? Let's zoom in for a minute, even though it will pixelate just a little bit, so we can draw attention to this spiral dust lane. Now let's go back out for a minute to our APS-C full frame so we get our maximum You could just copy and paste from the chat, Doug, like I do from Wikipedia. You're right, Stu. You're right. So it's one of the largest and brightest spiral galaxies with an absolute magnitude that has been estimated to be -22. Now, absolute magnitude compares every object to a standard candle distance. So if the sun were a candle, it compares everything to a certain distance. Do you guys remember what is absolute magnitude 1? Is it Sirius? I forget. Anyway, whatever star we use to be our absolute standard candle, -22 would be outlandishly bright. And sure enough, it looks bright to us on this dark night. Moonless night. This is a beautiful galaxy. Let's see what else O'Meara says. At the turn of the century, it was photographed by James Keeler, and it was among the first spiral, quote, nebulae, unquote, that he photographed. And as he compared photographs, he began to realize this is not a cloud per se. And he thinks that over time, it might be possible even to see the rotation. It's spinning so quickly, he thinks. So other guys have compared the rotation people use this to be the standard for explaining what a spiral is. A fuzzy halo of light, soft, transparent as angels' breath marks. Knotty, regular arms swirl away from this core in luminous concentric rings lined with very strong dark lanes. The outer regions are very dusty. The intensity of the nucleus and the symmetry of the rings gives the galaxy a look of quiet calamity. Metal rich. Now, am I right that metal is basically anything besides what? Hydrogen and oxygen, is it? So it's when you start seeing lots of other compounds and elements besides hydrogen and oxygen. It doesn't necessarily mean that there are hunks of iron floating around. It means that when you describe a galaxy that way, it's gases and elements other than hydrogen and oxygen, I think. Lots of star activity, keeps it young, tells how to find it. Consider that in physical size and mass, around 91,000 light years, it has 190 billion suns. It's comparable to our Milky Way. So you're staring at it edge on, you kind of shrug your shoulders. Imagine how an alien observer from another galaxy might feel seeing our Milky Way 55 million light years distant through a small telescope. It is a failing of human nature that we can so easily, brush aside anything that does not immediately appeal to our visual senses. Our inability to fully comprehend all that we see is one of our greatest weaknesses. It's the brightest of 3 edge-on systems in this field of view. And there you can see all three. One here, one there, and one in the middle. It's like the Virgo triplet. In light of the profound nature of all these dim and distant systems in the Coma Virgo cloud, it is almost nonsensical to look out into the vastness of space with our telescopes and not contemplate at least the possibility of life elsewhere in the universe. That curiosity is what sets us aside from other forms of life on Earth. It is what makes us distinct beings, though not necessarily unique in a cosmic sense. Harlow Shapley said, "Our failure to comprehend the universe is that we have been, and still are bedeviled, by a natural and persisting anthropocentrism. Correctives for our vanities are provided by modern science, but we suffer relapses and return to believing that we are somehow important and supremely powerful and understanding. Of course, we are not." Wow. So at 10 minutes, this is a beautiful galaxy. Look at it. Kind of spinning there. So let's do a stop shot, saving this live stack exactly as seen. And we've got our own view of a Virgo deep field. We're on 4216, yes. Omira waxing philosophical, right, Stu? He was on a bit of a downer that night. Yeah, that's probably true. That's funny. Okay, so we'll finish this off by saying, wow, a perfect example of a spiral. And we'll finish this and we'll now go to 4361, NGC 4361. $43.61. And you can see we're kind of in the same part of the sky. Now we're inside Corvus, which I think is supposed to be a crow, right? I don't know if that looks much like a crow to me. Let's put on our art for a second. I don't know if that helps. So this star here is supposed to be the eye. Oop, let me show you the screen, sorry. So this is supposed to be Corvus the crow. We'll put on the art for a second. And there's the crow. So Minkar is supposed to be the eye of the crow. And this up here is the wing. There's a foot of the crow, and this is the beak. Al-Chiba is the beak. We're looking east-southeast. I'm sorry, south-southeast. This might be a good time to pause and look at the sky cam to see the building maybe. Let me come over to where you are. Here we go. There's the truck, and there in the corner of this view is my lit window. So this is a good time tonight for me to go over to the window. I'm going to take out my flashlight, and I'm going to raise the shutter, open the window. First, I'm going to try my red light. Are you able to see my red light? Let me see if I can make it any brighter. There, I bet you can see that. So there's my red light. Now I'm going to change it to white. There's my white light. So that's the window where I'm observing. And now I'm going to come back and ask, were you guys able to see that? So as you can see, that's a live view. Okay, so now let's go over to where we've been stacking all this time while I've been talking. See, we didn't waste any time. We've been stacking. We also plate solved automatically. All that happened automatically, robotically. Oh, look, there's the planetary nebula right in the middle. I don't know how this is going to line up. Let's keep it just a little bit left for a planetary nebula. That's a nice looking planetary nebula. Wow, look how you can see almost a, here's what happened it looks like. When this central star jettisoned its first batch of material, look how it must be turning really fast. And the material, as it was ejected, it's forming this kind of S deal here. Wow! Now I'm at 175 degrees of the ability of our APS-C size sensor. That's a little better. 154 degrees. But can you make out, no, you're not switched over to the right view yet. Look how you can see this outer jettisoned gas stuff. And as it was spinning, it turned that into sort of like a spinning top kind of thing. Now this other halo that you see looks like it was another ejection of gas at a different time, maybe. That's my theory and I'm sticking with it. So this is one ejection and this is another ejection. Now when it ejected this shell, that shell just went out like, you know, a firework that's exploding on a shell kind of thing in all directions. But look at this unique S shape. Now there's even another outer shell that's even lighter here. We're seeing all this after just 3 minutes. This is amazing. Let me see what you guys are saying here. Only see the sky cam. Oh, Azray finally saw it. Yeah. So you were seeing the flashlight using the sky cam to view my window. See? Now we switched over. Oh, Azray, you're following along with your 80 millimeter tonight. That's amazing. That's pretty cool. Doing a follow along. That's awesome. Tell you what we're going to do, we're going to boost up these mids a little more. Now see how it's tinted just a little bit green? So that would indicate a bunch of excess hydrogen, or oxygen out there maybe. Wow. Let's go to this, which is 4361. NGC 4361 wiki. Yeah, there's that S-curve thing that we can see. Here's that outer puff, and here's the inner puff, and there's the central star. What do we need with Hubble? Was this Hubble? This is the 24-inch RC Optical on top Mount Lemmon. So it's a Ritchie-Chrétien optical, 24-inch. What do we need with a 24-inch telescope? Let's go back and, so the central star is extremely hot. Good, you're right, Stu. It's a Wolf-Rayet type star. And it's the hottest known non-neutron star. 18,000 times brighter than the sun. Only 6% larger than the sun. So that's the central star. But tell me something about this, why do we see this pattern? If this thing's not spinning around fast, making that pattern. Anybody tell us that? You're running at 360 millimeters. Cool. So I'm just going to say, at just 3 minutes, we could see 3 distinct patterns of ejected material. The first pattern is the S-shaped material jettisoned to the polar regions of this planetary nebula. That is the north-south poles of this thing. The second is a globe of oxygen now being lit up by the super bright Wolf-Rayet type star. Extremely hot. And then I pasted in that wiki like you told me to, Stu. Stu says it's an asymptotic giant branch. A whole page of it on Wikipedia. I love it, Stu. Thanks for finding that. So is it indeed sent out toward the poles, as we guessed? A pink ring with a turbulent aquamarine outer shell across 2 light years, and an even faster central bipolar outflow, which makes it sound like it needs to go to a psychiatrist and get some medicine. You're using a reducer, 4.6, good, Azray. I bet that's giving you that good, fast focal ratio. The interaction of these symmetrical outflows with the halo has already produced notorious signs of deformation, a complex curdle experience, tenuous vapors with a stick, shock waves. Unanimously one of the finest non-Messier non-objects of its class. Fainter lobes can be seen oriented northwest-southeast, gives it a clover leaf appearance. Contrast between the arms and the surrounding halo, which we saw. You see those knots. I love the way we can see this, propeller thing on the outside. The polar projections are very propeller-like in their shape. This star is turning fast. That's awesome. That's 10 minutes of integration there. These are hidden treasures, aren't they? you can't really skate through these quickly, can you? This next object is an open cluster, OCL1001. OCL1001. It's not a common catalog, is it? Stu says, crikey, that gets heavy. I'm not going to try to explain that, or the I'm not going to try to do any kind of shortcut from the wiki version. Some light bedtime reading guaranteed to put you to sleep. Okay, Stu, thanks for checking that out for us. Okay, so there we are in the same general patch of sky. We'll go to Stellarium. And we're in the same general patch of sky, but instead of being off the tail now, we're back over into Coma Berenices. And this is the cluster we're viewing. The Coma Berenices cluster. He calls it, Stellarium calls it CR256. Number 62 in his hidden treasure list. It's known as the Coma Berenices cluster, Berenices hair, Ariadne's hair, Thisbe's veil, Cobweb cluster, Black Bart's hair, Flying Witch, Malot 111. Okay, Stu, catch this. Oh, this is OCL 1001, Asray. Catch this, Stu. On cool spring evenings, when Leo is leaping high across the meridian, and Arcturus in Boötes burns brilliantly above the beast's lower shanks, another constellation, dim but glittering, fills the void between them. Large and inconspicuous, Coma Berenices hair, is a 5-degree wide spangle of 7 prominent and twice that many fainter naked eye suns that glitter like dew on a cobweb under the cold light of the moon. He's getting philosophical again. And then he tells about finding this cluster, and he says it was discovered in, or first described by Konon of Samos in 280 to 220 BC. He described it to King Ptolemy. I guess the king said, "You could have told me so." Oops, that was bad. It's mentioned throughout history. Oh my goodness, he's got so much history of this. Oh my goodness, this goes on and on. The cluster is not that old, he thinks. Fairly young as clusters go. He describes it by all this history when light left the cluster, and a lot of this stuff has nothing to do with the spiral. He's just trying to anchor it in history. Wow. Look at the way these incredibly bright stars are just burning. Let's do this display histogram. Let's see if we can fix this a little bit. But look how bright those are. Wow. 3 minutes is plenty for this, right? But it is beautiful. Imagine not finding this if you're Messier. A little bit, just a little bit embarrassing, right? Coma star cluster. Melot 111. Colander 256. Small open cluster. 40 brighter stars. Between 5 and 10 mag. Huh. It used to represent the tail of Leo. How interesting. But in 240 BC, Ptolemy, so the third, renamed it for Egyptian queens, Queen Berenice's hair. Oh, that's nice. The astronaut Donald Pettit took the photo used in the wiki article. So, Coma star cluster, huh? Coma star cluster. Oh yeah, you're right. Donald Pettit aboard the International Space Station. Go Donald. He's a astrophotographer. Look at that. It's beautiful. All right, off we go to NGC 4490. NGC 4490. You know what's interesting? The OCL clusters don't show their observations correctly. I'm going to report this now. OCL. I think I reported this once before, but I'm going to report it again to the maker of Deep Sky Planner. I'm going to say OCL clusters don't report observations correctly. It doesn't show the observation. I find that to be very interesting. Okay, back to the screen. Oh, I was afraid of that. I must have not slewed there. Because this cluster GC 4490 Okay, now we're looking at it. 4490 is evidently the Cocoon Galaxy. Yeah. Also known as the Cocoon Galaxy. I could have just asked Stu. That would be a cool place for stargazing, right, from the ISS. It's a barred spiral in the constellation Canis Venatici at a distance of 25 million light years. William Herschel discovered it in 1788. It interacts with its smaller companion, NGC 4485. As a result, it is a starburst galaxy. NGC 4490 and NGC 4485 are collectively known as in the Atlas of Peculiar Galaxy as ARP 269. So these two together are ARP 269. Thanks, Stu. So this is 4490, and that is 4485. Cocoon, and this must be the thing crawling out of the cocoon. Stu pointed out that this together with NGC 4485 make up ARP 269 interacting. 25 million light years from Earth. Barred spiral starburst. Very interesting. Oh yeah, from the first exposure we're seeing it. You know, these hidden treasures are more interesting, aren't they, than the Herschel 400 was. I hate to say that because it sounds like I'm disrespecting the Herschel 400, and I don't mean to do that at all. But these are just kind of cooler, aren't they? That's a bright star there, isn't it? This is just 40 seconds. This is bright. And big. Remember those objects we were trying to see in the Herschel 400? I mean, you had to have a microscope to see some of them. This thing looks huge. Why is this not in the Messier list? 4490. It's object 63. Definitely easier to see. It can be observed with binoculars, Stu says. Oh, it is a Herschel 400 object. Well, Stu, you just betrayed the fact that the way this catalog works, when it's listed as a different first number catalog item, it doesn't find the observation of it. So Hidden Treasure 63 is also a Herschel 400 object, huh? You're right. Why did we not remember this? We must have looked at this on a bright moonlit night or something. He says they're both embedded in a very large symmetrical envelope of neutral hydrogen gas. Interacting galaxies. 4490 is inclined 65 degrees from face on. A ringtail core wrapped in a cocoon of stellar filigree. What is filigree? He's used that word twice. Definition of filigree. Ornamental work of fine, typically gold or silver wire, formed into delicate tracery. Delicate silver filigree earrings. Okay. So now, with that in mind, yeah, I think he's right. It does look like all that silvery fine artwork, doesn't it? Stu says he's never seen it before. It's an astronomy lesson and a vocabulary lesson. Well, it sure is. If you're going to read O'Meara, it sure is. Galaxy's northwest end looks warped. Yeah. Here it does a bizarre drip of starlight that makes a dogleg toward 4490. I'm sorry, 4485. Yet another pool of tortured nebulosity surrounding the galaxy's companion. 4490 looks like an eviscerated galaxy, one whose entrails have been ghoulishly ripped from the carcass and tossed wildly asunder. Oh my goodness, that is so violent. We need to rate this with a higher rating now for age. Massive, robust star formation. To find this enigmatic wonder. The S-shaped pattern is real. The S is not related to the spiral structure. The core is so bright. The nucleus seems to ignite with fairy dust. Bright dots along the major axis near the center. Dark band passing along the north side of the nucleus. Yep. Says you have to have a 12-inch telescope to see that. You can either have a 12-inch telescope or you can have an 11-inch and use EAA. Because look at that dark band. There's a dark band here and then a dark band here. And look at these stars in a row. It's like lights along a shoreline. Look at that dark band there, so you can see this propeller, and that propeller is being warped by this attraction. These things are on a fatal attraction warpath. This is worth one of those close-ups that we sometimes do. I don't really like that framing. Let's try it again. Let's get these stars in. These three over here. There we go. That's better framing. Maybe that one. And then we're going to save this as desktop sharp cap captures. We're going to save it as MGC 4490. There's where we stacked it before. Or maybe that's where we just took the pictures of it. April 17th, yeah, that was tonight. We just took those with SharpCap. 4490 at 7 minutes. And it also has NGC 4485 in it. And it makes up ARP 269. Very helpful, Stu. That's a keeper. That's a cool picture. I don't really want to leave that. He is quite verbose, and you're right. Asray says, yep, RASA and EAA rock. Yeah. Okay, so this is amazing. Next one is, can I just check this manually? Yeah. No, it doesn't stay checked. That's weird. 4526. 4526. Let's move through these as rapidly as we can. See if we can't finish up these 1, 2, 3, 4, 5. Is that impossible? In 15 minutes? That would be 3 minutes apiece. Let's try it. NGC 4526. And I'm going to show chart. See where we are. Ooh. So we're in Virgo's arms. The lost galaxy. Mysterious name. NGC 4526. I don't know what Prolix is. You're right, I skipped over it, didn't I? You know me well, Stu. You got my number. I skip over the words I don't know. Lenticular, also known as NGC 4560. How interesting, 2 NGC numbers. Embedded in dusty disk. 55 million light years from Earth in the Virgo. Oh, right there it is. Right away, I'm going to start that on a plate solve. Just solving only, not moving again. And then let's several treasures here, huh? So this is NGC 4526. Here's 4535. This is 4519. So 4535, 4518, and 4519 are all visible. 4535. Also visible. 4535, 45, was it 4518 and 4519? Yeah, 45, 18, and 19. 45, 18 and 19. That's like sort of a Herschel 400 galaxy we were looking at in those last two nights of the Herschel 400. But look at this, 4519. Made a cool S shape. I think that's a neat hidden treasure. Wonder why. Maybe that was in the Herschel 400. Hubble took a photo of this in '94 when a supernova was reaching its peak in the outer edge. We've seen this one recently, last few months. I bet you're right. Okay, next object. It's been 3 minutes. We got to move on. Is NGC 4656. 4656. Looks like it's settled already. Must not have moved far. (4656). The Crowbar Galaxy. Yeah, you know, I think we saw the Whale Galaxy just the other night in the Herschel 400, but I don't think the Crowbar Galaxy was in the Herschel 400. So we should be able to see the Whale Galaxy again. And for context, we're between Coma Berenices and Ursa Major, or Canis Venatici, between Coma and Canis. Highly warped spiral bar galaxy in Canis. Hockey stick or crowbar. Near Whale. Yeah. Look how it has dust going off the back side of it. This is pretty big. Look, we're at, for comparison, that's 100% of the APS-C sensor. So this galaxy's huge. Boy, it is seriously interactive, isn't it? This looks like a starburst galaxy too. Does it say anything about that, Stu? Next object, 4699. Sorry, I got the drinking on them. I got the drinking sound on the microphone. I should have muted myself. That would have been more professional. 8 of us here tonight. Who are the 8? If you guys don't mind, tell us who they are. Azray, Stu. I wonder if Mike Jerry's computer is still on. Mike Fireberg, are you still on? Books, maybe? I probably count as 1. Oh, 2 just hopped off, so they wouldn't have to tell who they were. That's awesome. That's funny. 2 people went poof. They just disappeared. All right, let's come back here to the screen. This will pop in here any second. Just finished its plate solving. I think we talked about plate solving before. If you're watching the video for the first time, you aren't usually with us, then let me tell you about plate solving. 4699. Just realized I have not been doing this, but it is a Galaxy in Virgo, so we had that part right. Plate solving is when the SharpCap software works with your plate solving software, and I'm using ASTAP, to snap a picture of the night sky that you happen to be viewing and compare it to its stored database, and then it re-synchronizes the telescope to the right exact field of view so the object is centered. So that lets us know this is definitely NGC 4699, Hidden Treasure 68. Mike, good to have you here. So you're working and watching at the same time. What do we know about this 4699, Stu? Those were probably bots. Yeah. Azray, glad you're still here. Mike's still here. 4699 is Hidden Treasure 68. Vinyl LP Galaxy. We did this the other night in the Herschel 400 list, didn't we? Multiple arm, mixed spiral. Whole disk is fragmented into countless arcs of matter with no clear spiral structure. Spiral ring of concentric, countless rings of concentric matter. Intermediate spiral, 65 million light years away, 85,000 light years across. Good old Herschel. Boy, we have followed him all over the sky, haven't we? Last 2 objects that are visible tonight. Oh boy. It just picked up 4 more, or 2 more. NGC 5102. Let's push to that one real quick. NGC 5102. 5102. This is Hidden Treasure 70. for context. Oh wow, this is lower, 15 degrees above the horizon. So there you see my window again. One more time. This is my window. See the light in the window? That's where I'm observing, 200 feet away. And here's the dew shield of the scope. The black dew shield. Okay, let me get back to where I was. So here's that window I just pointed out is right here. And there's my truck in front of the observatory. By the way, we're getting a new sidewalk here, connecting it to that road. So once we get the sidewalk done, I think we can have an actual dedication. We'll do the dedication online so you guys can be a part of it. We'll do some kind of punch and cake or something, I don't know. Anyway, here's where this is. IOTA's ghost, apparently. NGC 5102, IOTA's ghost. IOTA''S. A lenticular. A lenticular in Centaurus. I need to change our title then, don't I? NGC 5102, a galaxy in Centaurus. I wonder if we did this one the other night in Herschel 400 too. $12.1 million light years away. Looked like a Herschel 400 object. Bow tie-like. I wish Deep Sky Planner would synchronize with other catalog listings so that it would show us observations of other objects, but it doesn't, alas. And Phyllis tells us that it's particularly hard to get software to do that because these catalogs are all so different. But I wondered, surely with the NGC number, that would be a point of comparison. But no, she said, catalogs aren't cooperating like that. So this is NGC 5363. NGC 5363. This is a galaxy in Virgo. $53.63. This is off of Virgo's kneecap. 5356 is nearby, as is 5364. We should be able to see all those. 5356, 5360, 5364. This is NGC 5363. lenticular 65 million light years, 100,000 light years across. Also in this frame, NGC 5356, 5360, 5364, and also 5348. Amazing. And some others there too. So the one we're looking at is here in the middle with the bright core and sort of out of balance halo. Looks familiar with the Herschel 400. And then these are those other objects, 5356, 5364, and 5348. 5363 is here in the middle. And then next is 5746. $57.46. $57.46. Stretching across 44 million light years. 5746, a barred spiral in the eastern part of Virgo. Oh, it's got an entire group is named after it. The 5746 group, like a motorcycle club or something. $95 million. 95 million light years away, nearly edge on. Oh, that's a cool galaxy. Look at this. I think we saw this one the other night, didn't we? In the Herschel 400. Obvious dust lane just below the central bulge. Came into view after just 80 seconds. That's amazing, isn't it? And this is 5746, 95 million light years away. And we see it in 80 seconds. It's amazing. after 100 seconds. It's beautiful. Okay, last one of the night. It also happens to be the last one that's visible. 5897. 5897. Okay. Globular cluster in Libra. You know, I have to do some work on this scope cam. I'll just replace it because it's just not showing up anymore for some reason. We can go to it again and again. I can't get it to come on. So I'll replace that. Do some maintenance on that before next time, hopefully. You might remember we had some trouble with the scope cam a while back, and it had come unplugged with the little extension cable that lets us reach it. But when I plugged it back in, it worked at first, but now it's just not catching. Several nights in a row, it's not connecting well, and then it'll connect after a while or something, but it's not at all tonight. So I'll just have to replace it. I ordered a replacement scope cam, you know, a new one in its place, but then after it worked, I used the new one at another angle out there that I would use when we're working from within the observatory later on when it warms up, and we're doing our live streams from out there in the observatory under the midnight sky, so to speak. We'll be able to live stream from out there because now we have Wi-Fi in the observatory, thankfully, and thanks to my IT friend Greg, who hooked us up with that. Wow, this is beautiful. This is 41,000 light years away, 170 light years diameter, apparent magnitude of 8.5. So just out of naked eye view. Naked eye view might teeter between 5 and 6. Cables are still last century, go wireless, Stu says. I'm well anchored in this fiber optic cable, Stu. Azray said he just came in from outside too. Got a little bit cold for you, I bet. This is beautiful. Azray, it's 823 degrees now. Is that like, I don't know, Kelvin or something? Anyway, this is a beautiful glob. For context's sake, that's 100%. So this is huge. Look at all the greens and yellows. All right, that finishes up this part of the hidden treasures list. So what this means is we are down to the last 17 objects in hidden treasures, and they are all, I'm sorry, the last 16, because this OCL one just won't come off the list because it starts with OCL and for some reason it doesn't clear off the list. The last 16, and we'll catch a few more of these in another month maybe. These will be up high enough. And then these others, they'll have to wait till another month. So, gang, we're making good progress. Just when you think that, you know, how long will it take to see all of these different lists? Man, I'm telling you, we are making good progress. I've already started prepping the next list, which is called Cosmic Challenge, I think it's called. And I told you about that the other night. Oh, 82 Fahrenheit, got it. As Ray clarified, not 823, it's 82 Fahrenheit. After we do the Cosmic Challenge, I just picked up another book, and I'll bring it and show it to you when we make a little more progress on the Cosmic Challenge. This other book is 1,000 Objects to See Before You Die. So we'll take a look and see how long it'll take us to cruise through that list. So the lists are unending. There's plenty out there to see. Just want to thank you for being a part of this tonight. You guys are faithful. And if you're watching this as a recording, thank you for sticking with us through this recording. Would invite you to click thumbs up if you haven't already done that. Invite you to subscribe, only if you want to. It doesn't cost you anything, but we would love to have you as a subscriber. If you click the bell, then it will notify you when we're going to come online. It'll give you like a YouTube announcement. The other thing you can do is go to our website, emeraldhillskies.com, and sign up on that front page. It'll explain how you send an email to sign up. And that way you'll be notified by email if you want. And that's pretty cool. It's a free setup. You don't get any spam. You just get notified, usually 24 hours or so before we do one of these, you'll get an email. So that'll help. You can like Emerald Hill Skies Facebook page. We don't mention that often enough. You can also, at the emeraldhillskies.com, look at our lists. And we're trying our best to keep them current. We've updated Messier with our marathon we just did, Caldwell, Herschel 400, and now we'll update the Hidden Treasures list. You can see what we have left. That's interesting. And since it's a team sport, you're kind of seeing what we together have left. I really mean that. Let's see, you can go to the YouTube channel, Emerald Hill Skies. If you just search YouTube for Emerald Hill Skies, you can usually find it. I think it's just youtube.com/ @Emerald Hill Skies, maybe. Maybe that's the way to find the channel. Anyway, just go there real quick in case you're watching this. youtube.com. Let's see. I'm going to go over here and just quickly go to the channel, and that'll give us, it's YouTube. Well, that didn't help us. youtube.com, and I'm going to hit the end key, / Emerald Hill Skies. That's what it is. youtube.com / Emerald Hill Skies takes you to our YouTube channel, and if you go to the store there, you can see all kinds of choices of merch. How about that? Bags and stickers and mugs and t-shirts. And then if you go to the spread shop, with any of these spread shop links, you can find more stuff. You can do the Australian shop if you're Bokes, or Stu might even want the Australian shop. You can go and look at like hoodies and stuff and get Emerald Hill Skies hoodies. We're also going to do more of these. Like one of the ones we're going to make is Astronomy is a Team Sport. We'll get those on there for you at the spread shop. So to get to that, you can say Emerald Hill Skies, I think. Well, it's better just to go to the YouTube channel and click on the link. You can also go to the Patreon site if you like, and that's just patreon.com/ I think Emerald Hill Skies. Right. Patreon, Patreon, patreon.com / Emerald Hill Skies, and you'll be able to sign up as a Patreon to help sponsor the channel if you want. And I've shared with you before that all the stuff we do in Patreon, as well as the, what is it called? The super chats, I think they call them, in YouTube. All this stuff we invest to try to help people that are hurting around the world. Currently, we've been sending it to the survivors of the earthquake in southern Turkey. But we just pick out a catastrophe that we can all sort of rally behind. And everybody on the channel, I think, that's listening right now live has already pitched in one time or another. The Patreon stuff goes to that as well. If there's income from that, we don't receive it here personally. We forward it right on to help with some family that's lost their housing or lost a loved one. So let me look one more time here. Mike says your stream helps me stay awake when I'm working late. Stu, thanks again for being a part of this, for all your help. Azray, thank you. I love it that you were working with us tonight. Mike needs sweatpants. Okay, check out the merch there with Spread Shop. They should make spread pants for you. We'll try to find those if they're not there, but you could go to the Spread Shop itself and find those, I'm sure. Guys, thanks a lot for being part of this. You're great. Sports, we went a little overtime tonight, 18 minutes over to finish these last few targets. Thanks for sticking with us. You guys are great. We love you all. Thanks for being part of this. We'll find the next clear night, roughly a week from now, whatever, and we'll hope to see you then. God bless. Good night from Emerald Hill Skies, and we'll see you next time. Thanks.